Our first scenario is while messing with the fish tank at Dr. Sherman's office, Darla causes the tank to start draining from a small crack at the very bottom of the tank. The tank is a 20-gallon tank, therefore it is 0.61 meters long, 0.305 meters wide, and 0.406 meters high. If the water level is decreasing at a rate of 0.2 meters per second, at what rate is the water being drained from the tank? We started with the equation for volume of a rectangular prism. Since we were given values for width and length, we were able to simply plug in those numbers to the equation. We took the derivatives of the remaining variables, and that allowed us to plug in another value to our problem, dH dt, the rate at which the water level was decreasing. After this, all that was left was to multiply the two values, which left us with our answer, that dV dt, the rate at which the water is being drained from the tank, is negative 0.037 meters cubed per second. Feel free to pause and read our reflection.
Nemo! Nemo!
Our second scenario is that Nemo's class is on a field trip visiting the edge of the reef that is 45 meters below the surface of the water when Nemo gets captured and put on the boat directly above the edge of the reef. The boat starts to move rightwards at a rate of 23.246 meters per second. Find the rate at which the angle between Nemo's friends and the boat is changing when the boat is 250 meters away from where it started. The question is asking us to solve for d theta dt, but first we must solve for the missing leg L and the rate at which it is changing, dL dt. In order to find the length of the missing leg, we simply use the Pythagorean theorem to solve for L, which we found to be the square root of 64,525. Next it was time to solve for dL dt. In order to do this, we once again used the Pythagorean theorem, and we found the derivative of each variable in the equation. After this, we were able to simply plug in each value that we had found or that was given to us and simplify, which gave us the answer that dL dt equaled 22.878 meters per second. Since we finally had all the variables necessary, it was time to solve for d theta dt. We started out with the equation sine theta equals x over L. Then we took the derivative of all parts and had to use the quotient rule, which left us with cosine d theta dt equals low d high minus high d low all over low low. Then we just plugged in the known values and simplified. In order to get d theta dt by itself, we multiplied both sides of the equation by the reciprocal of 45 over the square root of 64,525. After simplification, we found d theta dt to be 0.0162 degrees. Feel free to pause and read our reflection.